Welcome to Our Sky and Stars. Today is something very special we are going to cover, and it is the pitot static pressure system. This is a twofold system, okay? Two sections. One measures static pressure, only static pressure. We're talking about the static pressure port. And the other one only measures dynamic pressure. The static pressure port on the aircraft is located at a position that is really protects it from damages and dirts, everything like that. Okay, so this is why it has to be located at a certain specific distance from a section, a station of the airplane. Okay. Once again, the static port only measures static pressure. And we all know the static pressure at sea level on a standard day is 2,116 psi or 14.7 psi. And the free airstream at sea level, V1, is 100 knots. Okay, that's the static pressure is P1. Okay, and V1 is the velocity of the air and of the free airstream entering the static port on the outside of a diaphragm that is very flexible. Okay, and the diaphragm can be moved very easily. Okay, by pressure. Okay, so on the outside of the diaphragm, we have P1. Okay, which is at sea level 2,116 psf. Okay, that's one. Now we are talking about the static pressure port section. Okay, remember we are dealing with two sections. Okay, P1 for static pressure enters the static port. Okay, now let us move to the second section, which is the pitot tube, the dynamic pressure section. The pitot tube system has a port that measures total pressure also called stagnation pressure, because when the free airstream, the ram air, coming straight at the pitot tube, some of the air actually stops, at the port. So that is one of the reasons why they called total pressure stagnation pressure as well. The pitot tube is placed at a location to face the airstream coming at it, and the airstream actually entering the pitot tube port on the inside of the little thin diaphragm is 2,150 psf, which is a lot. So now we have a very thin diaphragm right in the middle of two measurements: total pressure on the inside of it, 2,150 psf, and static pressure at sea level, 2,116 psf. Two big numbers, and if you apply any of those two numbers to move that little flexible thin diaphragm, your airspeed indicator in the cockpit would go crazy, and for sure the diaphragm would be completely destroyed. It would be destroyed. So that is why those numbers, total pressure, static pressure, they're not specifically used to push the diaphragm for your airspeed indicator to react, to display, the airspeed. What is used instead is differential pressure, which is total pressure on the inside of the diaphragm minus static pressure on the outside of the diaphragm will give you pressure differential of 34 psf. That is the number. Okay, a dynamic number, 34 psf, that moves the diaphragm smoothly, okay, accurately, and then your airspeed indicator responds to that. And then you see the airspeed that is the correct one. If I said 34 psi at one point in the video, that was wrong. It's 34 psf. Okay, 34 psf. That is the correct terminology. So things you need to remember: we have P1, that is the static pressure at sea level. We got P2, that is the dynamic pressure on the inside of the diaphragm. We have Q1, which is the differential pressure, 34 psf, and then we have H, which is total pressure, that is static pressure plus differential pressure. And of course we have V, velocity of the free airstream, which is V1, 100 knots on a standard day at sea level. So that is basically the system with two sections, static pressure, dynamic pressure, and then boom, differential pressure, to which the airspeed indicator responds to display the airspeed. So the diaphragm actually moves the needle of your, I guess, analog airspeed indicator. Okay, that's it, and there's nothing else to say about it at this moment. So take care, and let's keep learning. Bye.